Let us solve a simple problem from statics. We have a beam given and we need to find out the reactions Ra and Rb. Remember that this is a beginning point for the SFD and BMT. Okay, but still it is in engineering mechanics because the reaction calculation comes in engineering mechanics. Okay, let's do this problem quickly. Okay, so for this we try to draw the free body diagram of the beam. Okay, with all the external forces as well as the reactions. A is a hinge, so I have AY and AX. Okay, because it restricts the motion in Y and X, so I have the reactions in Y and X. This is a roller, so I have B, Y. Remember, the answers are in RA and RB. So basically, RB is BY. So once I get BY, I just substitute it as RB, and AX and AY combined will be RA. So we'll do that. We'll see that what is RA, because it is, if AX is positive and AY is positive, it's root over AX square plus AY square. Okay, and now the you have a UDL, uniformly distributed load, which I can substitute with a single load which is acting at the center of the UDL, and with the value of the load equal, so I am replacing a UDL with a concentrated load, and the value will be the intensity of the UDL W into the length L on which it is acting. So this is 300 meters, beg your pardon, 300 mm, and this is also 300 mm. Okay, and I keep this exactly at the center, which is 150 mm. This is how a UDL is replaced. Okay, okay, so now this is in equilibrium, so I keep on applying all those equations of equilibrium. Okay, but let me first write out what is W into L. Now the intensity W is 6 kilonewton. Kilonewton is 10 power 3 Newton by meter, which is 10 power 3 mm. So I convert everything in Newton and mm. Length is in 300 mm. So this comes out to be 1800 newtons. So 1800 newtons of concentrated load is applied there. Okay, and that is the thing. Okay, so now sigma Fx 0. So all the three equations, because it's a planar problem, so three equations of equilibrium will get applied. Sigma Fx 0, sigma Fy 0, and the moment about any point of your choice is 0. Sigma Fx 0, you have only the horizontal force Ax, so Ax is 0. Okay, and sigma Fy is equal to 0, so taking upward force is positive, so Ay plus By, and your minus P is downward, so minus 1800 is 0. A moment about which point, any point is 0, I take it as A because A has two unknowns. Okay, Ax and Ay. Ax is anyhow 0, so I take it as Ax Ay 0. So this P, so clockwise movement I take it as positive. It's again a matter of choice. You can take anti-clockwise also, it doesn't matter. So 1800 is acting down, so 1800 into the length is 150, the moment arm, so that is clockwise. By is upward, and By will produce an anti-clockwise. It takes to rotate the bar in anti-clockwise direction. So minus By into the complete length, which is 600, is equal to 0. So By from this is 1800 by 600, 3 into 150 is 450. So 450 newtons is By. So RB is basically By, which is 450 newtons, and therefore it's 4.5, because the answers are to be in kilonewtons. Okay, so this is one, and now if I go back and substitute here 450, I get Ay is 450, that is 1800 minus 450 newtons. Remember, the equation is still in newtons, so it's 1350 newtons, and that is 1.35 kilonewtons. Remember, you don't have Ax, so Ray will be directly AY. Okay, otherwise you would have taken square root of the, you would have taken the resultant. So 1.35 and 0.45. 1.35 and 0.45. The answer option is C. The option is C. Thank you.